A percentile describes the percent of observations less than a certain value in a distribution. So for example, if I got a 60% on a test and 5 out of 50 students in my class got less than 60%, then I would be in the 10th percentile. And using percentiles, we can create cumulative relative frequency graphs, which look something like this. On the x-axis, you place your quantitative variable. In this case, it's the grade earned on a test. And on the y-axis, you place your cumulative relative frequency. So for example, for 60% on a test, you would be in the 10th percentile, 70, you would be in the 30th percentile, and so on and so forth. And then onto standardized scores, which are more commonly known as z-scores. They show you how many standard deviations from the mean an observation falls, and also indicates its direction, meaning that a negative z-score shows you that your observation is smaller than the mean, and a positive z-score shows you that the observation is greater than the mean. And this is the formula for finding a z-score. You take your observation, subtract the mean from it, and put it all over the standard deviation. That gives you the z-score. Let's look at an example. So let's say I got a 90% on a test, and the mean for the class was 85% with the standard deviation being 5. To find the z-score, we do 90 minus 85 and put that over 5, and that gives me 1, which means that I'm exactly 1 standard deviation above the mean.
Now that we know how to use percentiles and z-scores to describe one's location within a distribution, we can now look at a type of distribution that plays a large role in statistics: normal curves. Normal curves are a family of bell-shaped symmetric density curves with the normal distribution specified by the mean, which is located at the center, and the standard deviation, which controls spread. We often use it to do statistical inferences with real data. All normal distributions obey the 68, 95, 99.7 rule. This rule describes what percent of observations lie within 1, 2, or 3 standard deviations of the mean. 68 of observations fall within 1 standard deviation of the mean. 95 of observations fall within 2% of the mean. And 99.7 of the observations fall within 3 standard deviations of the mean. These can be used to estimate the percent of observations in a specified interval. For the rest of the video, we'll exemplify this with a standard normal distribution, using a standardized z-score and a mean of 0 with the standard deviation of 1. We can use this to find a proportion of observations that are less than, greater than, or in between values of z. Remember that the total area under a density curve is 1. So by using a calculator or table A, we can find a desired proportion, which was this value shown here. Here's an example of a problem that will highlight a common student mistake. During an exam, you may either use a table A or calculator to determine the percentile of a given z-score. A common student mistake is to look up a z-value in table A and report the value given, regardless of whether the problem asked for the area to the left or to the right of the z-value. To prevent making this mistake, always sketch out the normal curve, mark the z-values, and shade the area of interest, which to us is the area in between.
The way to get to a list of them is to push second and then to push distribution. And that gets you to normal PDF, normal CDF, inverse norm. These are the 3 main ones that you're going to use. So if I click on normal PDF, you can see it wants you to enter x value, the mean, and the standard deviation. For the sake of this example, I'm going to stick with 0 and 1, so it's a standard normal distribution curve, but you could also do this with other distribution curves with different means and different standard deviations. 0.25. Probability of that occurring is 0.38666. Normal CDF is for a range from, say, negative infinity to x or x to infinity. So if you calculate a z-score and you want to find the probability of something up to that z-score occurring or past that z-score occurring, you would use this. To do that, you push second, distribution, normal CDF, and find the probability of something occurring up to 1.65. For a standard normal distribution curve, you just paste that, press enter, and that probability is 95. Final value is inverse norm. You could use it to find z-scores. So for example, if I want to find the z-score at 0.75 in the normal distribution, I'd keep the mean at 0 and the standard deviation at 1 to make this a normal distribution curve. And bam, that's the z-score right here for 75%. Tips, tricks, and common mistakes for normal distribution curves. On the AP test, always show the formulas you use and make sure that you demonstrate your knowledge of the z-score and that you know what each variable you're putting in means. Also, on similar problems, show that a normal distribution curve and shade what you're looking for. That way you can demonstrate to the test grader that you know exactly what's going on.